In this video, we're going to look at a simple classification learning algorithm known as 1R. In the previous video, we saw that a classification learning algorithm takes a set of training data that has already been classified in some way, and it learns a model that is able to classify examples that were not seen during training, new examples whose class we don't know. Another way of saying that is the model takes the values of some input attributes and it uses those inputs to predict a value for the output attribute, which is the class. We saw in the previous video one example of such a model is a decision tree. That particular decision tree took information about customers like their age, whether they were a student, and their credit rating, and it predicted whether that customer would buy a computer in the next year. In this video, we're going to look at a different problem, which is a credit card company that wants to figure out whether to send customers promotional materials for a life insurance offer. So they want to be able to predict whether the customer will accept that offer, yes or no. And so they want a model that will predict either yes, the customer will accept it or not, and that model is going to be based on information about the customer. Those will be the input attributes. And so let's imagine that we have these 15 training examples. Again, this is artificially small. You would want as much training data as possible. Our output attribute is this last column here. Did the customer accept the life insurance promotion or not? The other columns, which are the inputs, are the customer's age, gender, income range, and then whether they accepted a previous offer for credit card insurance. Again, that's just a yes or no attribute. To learn the model, we're going to use a simple algorithm called 1R that was developed by R.C. Holt. The name 1R comes from the fact that it develops a set of rules, so that's where the R comes from, and those rules are based on only one of the input attributes, and that's where the 1 in the name comes from. The basic idea is to figure out a separate set of rules based on each of the input attributes. So we'll have one set of rules based on age, one set of rules based on gender, etc. And then we'll pick the set of rules that has the highest accuracy on the training data. So let's start by determining the rules based on gender. So here's how it works. We're going to say, okay, how many different values of gender are there? So in this case, there's just 2, and therefore we're going to need to have a rule that looks like this. For each value of the input, we're going to predict the value of the output. And the way we determine the prediction is by actually looking at the training examples that have each of those input values. So if we look at the female training examples, we can see when we look over here at the output column that a majority of them are yeses, and therefore when gender is female, we're going to predict yes. It is the majority class, 6 out of 7, for the examples in which the gender is female. Then we look at the examples in which gender is male. And here the majority is no, 5 out of 8. And so our prediction when gender is male is that the customer will not accept the life insurance promotion. And so that gives us this set of rules. And we also want to figure out how accurate they are on the training data. To do that, we add up the cases that they get right? So we have 6 of the female cases and 5 of the male. That gives us our numerator, and then the denominator is the total number of training examples. So our accuracy here is 11 out of 15, which is roughly 73%. We then repeat the process for each of the other input attributes. So for example, credit card insurance is another input. It has 2 possible values, yes and no. If we look at all of the yes cases, there's only 3 of them, every single one of them has a class value of yes. And so our prediction is going to be yes whenever credit card insurance is yes. When we look at the no training examples, we can see that there's a tie. 6 of them have a class value of no, 6 have a class value of yes, but we're going to pick no here because we already predict yes when the credit card insurance value is yes. So you can break the tie here in a way that seems most appropriate. When we compute the accuracy of these, you can see it's 3 plus 6, or 9 over 15, which is 60%. So not as accurate as the ones that we developed earlier based on gender. If we look at income range, it has 4 possible values, and so the rules based on income range are going to need a prediction for each of those 4 values. If we look at 20 to 30K, you can see it's a tie, so for now we'll remain undecided about whether it should be no or yes. 30 to 40K, clearly the majority is yes. 40 to 50K, clearly the majority is no. 50 to 60K, it's clearly a yes. And so if we look back at the 20 to 30, because we have 2 yeses and only 1 no, we're going to break the tie in favor of no, but it's not essential that we do that. We could also have broken it and predicted yes there. If we compute the accuracy, this time it's the same as what it was for gender, 11 over 15, or 73%. Now, the rules based on age are more complicated because age is a numeric attribute. And so we're going to need to discretize the range of possible ages into subranges that are sometimes called bins or buckets. There's different ways of discretizing. The simple approach we're going to take here is first to sort the training instances by age. And so down here I'm going to sort them from lowest age to highest. And with each age I'm going to include the class value. And so you can see the youngest person here is age 19, and they are a yes, so I'm putting a Y there. The next youngest is this 27-year-old male. He did not accept, so I'm putting a no down here next to his age. And then we just keep doing this until we have it fully sorted. And then we're going to look for a two-way split, a binary split, that is as accurate as possible. So one possible split would be here, where you're saying everyone whose age is less than or equal to 39, because they're to the left of the split, we're going to predict one thing. And everyone to the right of that split, everyone whose age is greater than 39, we're going to predict something else. And based on the majority of class again, you can see that the majority of the people on the left of that split are yeses, 5 out of 6. The majority on the right are no's, 5 out of 9. That accuracy is 67%. But it turns out there's a more accurate split, and basically you have to just keep trying splits until you find the most accurate. And one of the most accurate is to put the dividing line here. Age less than or equal to 43, we predict yes. And age greater than 43, we predict no. That actually has a very high overall accuracy of 80%. And so those are the rules that we're going to keep for age. And then if you look at all 4 sets of rules, and then we are going to pick the one whose overall accuracy on the training data is the highest. In this case, it is the set of rules based on age. And so this set of rules over here is the 1R model. So you try all of the possible sets of rules that you could develop, but the final model, the final 1R model, is the set of rules that gives you the highest overall accuracy on the training data.